In this video we are covering sections 3.1 and 3.2 from your book, and we're going to be introducing the idea of graphing linear equations in two variables. Now before we can do that though, we need to talk about the rectangular coordinate system and more specifically how to graph points. And so we're going to start out with talking about what a point is. We typically refer to it as an ordered pair, and in that name, ordered pair, there's two words that are important there. The first there is ordered, because order does matter. Order matters. And the reason why I say that is because always x comes first. X comes before y does. So you'll notice when it's written there, x comma y, the x number is always the first number, and then second is the y number. And then of course the word pair is there because there's two numbers. There's x and y. So kind of like when we talked about linear equations in one variable, the first thing we did was check to see if a value was a solution. In this case, we're also going to check to see if we have a solution to a linear equation. But here, because the linear equation has two variables, x and y, the solution has two values. X equals 3, y equals -6. The x value is 3, the y value is -6. And so we can go ahead and check this. We can take our equation, 4 times x, and remember when we plug in we put parentheses. And what's our x value? 4 times x, our x value is 3. Then we have -5. We're again plugging in, so I'm going to put parentheses in there for y, and y is -6. And then that should be equal to the right hand side of the equation, which is 42. Go ahead and simplify. 4 times 3 is 12. And then we have -5 times -6 is a positive 30. And that is in fact equal to 42, because 12 plus 30 is 42. So it does check out. Yes, the point 3, -6 is a solution. Great. Okay. So let's, now that we've talked about what an ordered pair is, let's go ahead and move on to the rectangular coordinate plane, also known as the Cartesian plane. You have a sample graph here, which is much different than the number lines that you've graphed things on up to this point in math. Number line has just one axis. The Cartesian plane, or the rectangular plane, has two axes. It has a horizontal axis, which is called the x-axis right here, and then it has a vertical axis, which is the y-axis. You have the y-axis and the x-axis. Notice though, just like the number line, 0 is in the middle. In fact, that has its own ordered pair right there. The origin is the point 0, 0. That means x equals 0, y equals 0. So on the x-axis, 0 is here in the middle, and then we have positive numbers to the right, negative numbers to the left, just like the number line. And then on the y-axis, that's the vertical axis, we have 0 in the middle. We have positive numbers going up, negative numbers going down. So what we can do is we can graph any ordered pair by knowing where it lines up in respect, where that point lines up with respect to the x-axis and the y-axis. So let's graph some points. We have the point 4, 3. Remember, x is 4, y is 3. So on the x-axis, we go over 4. 1, 2, 3, 4. That's right there. This is 4. I'm not going to label every tick mark. I don't think that's always necessary. And then on the y-axis, y is 3, so we'll go up 3, because remember our positive numbers are up, so we go up 3. 1, 2, 3. There's 3. And so if that's x equals 4 and that's y equals 3, those correspond to a single point that represents both x equal to 4 and y equal to 3. And that point is right here. That point lines up with 4 on the x-axis. It lines up with 3 on the y-axis. So that point, or that ordered pair, is the point for 3. And you absolutely have to be able to do this. This is so crucial for any math class going forward. You have to be able to graph points. So if you don't understand it, make sure you rewatch this part of the video, or you go into the math lab and ask questions. Next point has a negative y value. We're going to go one more on the x, so x is 5, y is negative 6. So x equals 5 is right here, and then y equals negative 6. Now we're going to go, instead of up, these are negative, so it's down 6 units. 2, 3, 4, 5, 6. There's negative 6, and so this lines up with this point right here, so this would be the ordered pair 5, negative 6. Go ahead and pause the video here and see if you can do the other two on your own. Place those other 2 points, and then when we come back you can check your work. Alright, welcome back. We now have the other 2 points listed on here. We have negative 7, negative 2, which is right here. Then we have negative 3, 0. Notice with negative 3, 0, the y value is 0, which means it's not above the x-axis, it's not below the x-axis, it's right on the x-axis because the y value is 0. Okay, so we've talked about points. Again, this is crucial that everybody knows how to graph these points. Now let's start talking about linear equations in 2 variables a little bit more. Specifically, how are we going to graph these? So by definition, a linear equation in 2 variables is an equation that can be written in this form. ax plus by equals c. A, b, and c are real numbers. Those are numbers. And a and b can't be 0. So this a can't be 0 and that b can't be 0. The reason why is if I had 0 times x, that would be 0. If I had 0 times y, that would be 0. And basically this whole left side would go away, which would make it not a linear equation in 2 variables anymore, because the x and the y would be gone. So I have an example. I have the linear equation in 2 variables, x plus y equals 5. And if we could just think about what are some solutions to this equation, well, one solution would be 2, 3. Why is that? Because 2 plus 3 equals 5. Remember, we're adding x plus y to get 5. And if x is 2 and y is 3, 2 plus 3 equals 5. How about 5, 0? How about 4, 1? How about negative 7, 12? You know, all these xy pairs, if you add them together, you get 5. So we could move to the next level here. How many solutions do you think this equation has? How many solutions does x plus y equals 5 have? Is there a limit to how many there are? Well, the answer to this question is that there is an infinite number of solutions. There's no end. They go on forever. How many solutions does any linear equation in 2 variables have? Same answer. There's an infinite number of solutions to every linear equation in 2 variables, not just the one that we looked at. Alright, so how do we find an ordered pair that is a solution to an equation? How do we, it was pretty easy in the last one we just looked at because we could just kind of see in our head 2 numbers add up to 5. It may not always be quite that easy. So in general, to find an ordered pair that is a solution to a linear equation in 2 variables, we pick a value for one of the variables, could be x or y, and we substitute that variable into the equation. We then solve for the other variable in the equation. Very simple to do. Let's look at an example. It says find the missing coordinate such that the ordered pair 3, something is a solution to the equation. So notice we picked an x. We picked x equals 3. We could pick any other value though. It doesn't have to be this one. This is just one of the infinite number of solutions. So when we pick that one and we plug it in, we get y equals, this is our equation here, y equals negative 3 times x, plug in parentheses, x equals 3 plus 5, and we can simplify here. It gives us y equals negative 3 times 3 is negative 9 plus 5. Negative 9 plus 5 is negative 4. So that's our answer. Our solution is 3 comma negative 4. If we plugged in x equals 2, we'd get a different value. If we plugged in y equals negative 4, we would get x equals 3. Now notice in this equation it's easy to plug in a value for x because y is already by itself. We could plug in x and easily tell what y is. And this is how we go about solving to find points so that we can graph a linear equation. So the next example says complete the table of ordered pairs with the solutions to the equations 3x plus 2y equals 18 and then plot those solutions on a rectangular coordinate plane. So our first, this is a table here. Notice we have an x column. These are x values. We have a y column. These are y values. And I'm going to go ahead and make one more column here, and this will be our ordered pair column. It'll be our x, y. So our first choice here is when x equals 0. If I plug in x equals 0, this equation becomes 3 times x, or 3 times 0, plus 2y equals 18. Of course 3 times 0 is 0, so this is 0 plus 2y equals 18. So we have 2y equals 18. 2 is married to the y, so we have to divide. Divide by 2. We get y equals 9. So here we have y equals 9, so that gives us the ordered pair 0, 9. We also chose x equals 2 in our table. If I plug in 2, I have 3 times 2 plus 2y equals 18. 3 times 2 is 6 plus 2y equals 18. Okay, remember if we want to solve, we need to get the y's by themselves, which means that negative 6 needs to go to the other side. Change sides, change signs. That goes away. We get 2y equals 12, and then we can go ahead and divide by 2. 12 divided by 2 equals 6. So when x equals 2, y equals 6, we get the point 2 comma 6. And then one more, I chose y equals 3 as my last one. Now notice we're plugging in for y and not for x. So this equation is going to look like 3x plus 2 times y, but y is 3, equals 18. Gives us 3x. 2 times 3 is 6, equals 18. Get this number over with the 18. If we change sides, we change signs, so that becomes a negative 6. When I do that, I get 3x equals 12. I can go ahead and divide both sides by 3, giving me x equals 4. So we have x equals 4, that gives us y equals 3. This is the point 4, 3. X comes first, then y. And now we go ahead and put these points on the graph. The first point is the point 0, 9. So x equals 0. Remember, this is our x-axis. This is our y-axis. So when x equals 0, we're on the y-axis and we go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We're way up here. It's the 0.09. Should have had a better set of axes here. Oh well. 2, 6. So we go x equals 2, y equals 6. 1, 2, 3, 4, 5, 6. Corresponds to that point. That's the 0.26. And then 4, 3. Go over 2 more on the x-axis. X equals 4 and y equals 3. 1, 2, 3. It's the 0.43. And notice, this is the beautiful thing, these points line up and we get a straight line. So in the previous example, what kind of curve do the graph points appear to be forming? A straight line. The linear equations in 2 variables always give a straight line. So how many points are needed to graph a line? Well, we really just need 2 points. The third point is kind of like a check. So you can pick any values you want. You could pick 1, 3, -2, anything you want. If I plug in 1, this is going to be y equals -2 times 1 plus 6. -2 times 1 is -2. -2 plus 6 equals 4. Let's do one more. I'm not going to do all these. If I chose, for example, x equals 3, this would give us y equals -2 times 3 plus 6. And -2 times 3 is -6. -6 plus 6 equals 0. So when x equals -3, y is 0. So if I take these 2 points, x first, then y. Here's x equals 1, y equals 4. Here's our y-axis. Is up here, so 1, 4 is right there. And then we could take the point 3, 0. X equals 3, y equals 0, so we're right here on the x-axis. That's 3, 0. And really 2 points is all we need to graph a line. So there's our line. Okay, so this is one way to graph linear equations. Another way of graphing linear equations is using their intercepts. And so that's what we're going to look at in the next section. And it starts off with a definition. An x-intercept is a point where a graph crosses the x-axis, and likewise a y-intercept is a point where a graph crosses the y-axis. So if I look at this generic line right here, we can see that here is the place where it crosses the x-axis. That would be the x-intercept, which is the point 1, 2, 3, 4. It looks like the point 4, 0, and then the y-intercept goes up 2 spaces, so this is 0, 2. Okay, so if I look at the y-intercept, that's right here, what can we say about the x value of the y-intercept? The x value equals 0. In fact, any point that's along the y-axis, since it's right here in the middle of the x-axis, x always equals 0. And likewise, what can we say about the y value of the x-intercept? The y value is also 0. We're going to use this to our advantage to actually formulate a method for finding x-intercepts. If we want to find the x-intercept, all we do is we let y equal 0 and we solve for x. And likewise, if we want to find the y-intercept, we let x equals 0 and we solve for y. And remember back to the last section, if we want to find points on a graph, we just do so by finding at least two ordered pairs or 2 points. And the way we find a point is we pick a value and solve for the other value. So in this case, to find the intercepts, we pick specific values. We pick specifically for x or y to equal 0 to find the intercepts. So we can do this on an example here. I have 5x plus 2y equals 20. Let's find first the x-intercept. If I want to find the x-intercept, remember we let y equals 0. If I do that, I get 5x plus 2 times y, but y is 0, equals 20. That goes away, which basically just gives us 5x equals 20. We can go ahead and divide. And we get x equals 4. So my x-intercept is the point 4, and then what's the y value? Remember, any point on a graph is an x and a y, so when x equals 4, we had to let y equal 0. Okay, and then likewise we can find the y-intercept. We do the opposite. We let x equals 0. So when we plug x equals 0, we get 5 times 0 plus 2y equals 20. And now the first part goes away, leaving just 2y equals 20. And we can go ahead and divide by 2 on both sides, giving us y equals 10. Of course, to do that, we had to let x, that's the first number in our ordered pairs, be 0, and y equals 10. So we can go ahead and graph those. I'm going to label these hash marks by 2 this time, so this would be 2, 4. So my x-intercept is at 4, 0, and my y-intercept is at 10. So if we go by 2's, we have 2, 4, 6, 8, 10. So that point could be the point 0, 10. We got our 2 points, which means we can graph the line. Okay. We also talked about graphing linear equations that pass through the origin or pass through 0, 0. Notice if I were to plug in 0 for x into this equation, what do I get? I get y equals negative 2 times 0. Anything times 0, though, is 0. So this particular line does pass through the origin. 0, 0 is a solution. And again, we need 2 points. We need to label at least 2 points, so pick another one, say 3. Okay, if I plug in 3, I get y equals negative 2 times 3. Negative 2 times 3 is negative 6. So there's another solution. We have 1, 2, 3. And then the y value is negative 6, so we go down 1, 2, 3, 4, 5, 6. 3, negative 6 is right there. And this is a linear equation that passes through the origin. Okay, the last type of lines we're going to talk about are horizontal and vertical lines. One of the things you notice about these is that they are actually only have one variable. The first example only has x, and the second example only has y. These are special exceptions to the rule of linear equations in 2 variables, because in this case it doesn't matter what y is, it only matters what x is. X is always negative 2, and x is always equal to negative 2 right here. There's negative 2, right? So really any point along that line could be negative 2, 0, could be up here, -2, 3. It could be a point down here, -2, -4. Any point on that line, doesn't matter what y is. Y could be anything, but notice x is always -2. So in this case, this is a vertical line. And you can probably guess then that when we have a y equal, we get a horizontal line. And this is because it doesn't matter what x is, it's the fact that y has to always be 5. So it could be that point right there. It could be 0, 5s on the line, but also say 3, 5 or -2, 5. There's an infinite number of solutions here, but the one thing that all these solutions on this horizontal line have in common is that the y value is always 5. So we get an equation y equals 5.
Okay, the last thing we're going to do is look at one application problem. It says Marcy owed $6,000 in student loans. She agreed to have $400 deducted from each month's paycheck until her loans were paid off. The amount of money y that Marcy owes is given by the equation y equals 6,000 minus 400x. Find the x and y intercepts and explain what they mean. So we just spent time finding intercepts, so let's go ahead and do that for this problem. We know if we want to find the x-intercept, what do? Do you remember? We let y equal 0, so we'll have 0 equals 6,000 minus 400x. Let that y equal 0. And then we want to get the x's on one side and the numbers on the other, so we can go ahead and move this guy to the other side. It becomes a plus 400x. And so when I do that, this becomes 400x equals 6,000. And if I divide both sides by 400, get rid of that, multiply by 400, divide both sides by 400, I get x equals what? 60 divided by 4, that's 15. Okay? Now let's do the y-intercept. How do we find the y-intercept? Y-intercept, remember, we let x equal 0. So we have y equals 6,000 minus 400 times x. What's x though? 0. Here we let y equal 0. Here we let x equal 0. So this just means y equals 600, or 6,000, excuse me. So our x-intercept is the point 15 with y 0, and our y-intercept is when x is 0 and y is 6,000. So if we put that on the graph, let's go ahead and treat these each as a 1,000. So that's 1,000, 2,000, 3,000, 4,000, 5,000, 6,000. And then let's go by 5. So 5, 10, 15, 20, 25, 30, etc. So at 15, that's our x-intercept, and our y-intercept is up there at 6,000. So our line will look something like that. Okay. Now let's interpret what these means, because they said we had to explain what it means. This guy, the y-intercept, means that, remember what these are. What is x? What does it say about it? She said she agreed to have $400 deducted each month. So that minus 400 is times x. X is the number of months. So this x-axis, this is months. And then the y-axis, this is what? Y is the amount that Marcy owes. So this is the amount owed. So this means at 0 months, she still owes $6,000. So this means maybe we could say Marcy hasn't paid back any of her loan. Because no time has passed. 0 months have passed. She hasn't paid back $400 once. So she still owes the full $6,000. But what does this one mean? Now 15 months have passed. And how much does she owe? Nothing. Marcy has paid off her loan. Hopefully that makes sense. Don't forget to do your self-check. 3.1, 3.2 self-check, and we will see you in class. Thank you.